Florida's geological nightmare is accelerating, and Miami's foundation is crumbling right now. This isn't a hurricane. This isn't a storm surge. This is the ground under Florida vanishing, like someone pulled the plug on the coastline. Picture waking up, and your beach is just gone. Not slowly, overnight. A giant hole opens under the water, and the sand starts sliding into it like it's being sucked into a drain. Tourists run out of hotels in their pajamas. Sirens scream. Whole stretches of coastline get shut down because officials can't tell what will collapse next. But here's the part that has scientists freaked out. Black tar is washing ashore, and tests say it isn't an oil spill. It's ancient material, trapped underground for thousands of years, suddenly leaking out through cracks that shouldn't exist. And then something even weirder happens. Florida starts having earthquakes. So what's really breaking beneath Miami? Just a few sinkholes? Or a hidden underground cave system that could turn an entire coastline into a collapse zone? December 18th, 6:47 a.m. Eastern Standard Time. A Coast Guard patrol boat glides across calm water off Deerfield Beach when the depth finder flashes something that makes no sense. 40 feet deep. But the official charts say 12. Lieutenant Commander James Walsh radios the coordinates twice, thinking it's a glitch. It's not. Within minutes, aerial surveillance confirms the unthinkable. A sinkhole nearly 300 feet across has opened on the ocean floor overnight while Florida slept. At 7:23 a.m., a second void rips open near Pompano Beach. This one is even larger, 450 feet wide. From the shoreline, tourists filming the sunrise catch the moment the sand beneath them starts sliding toward the water. The beach doesn't wash away. It sinks. Sirens wail across Broward County. Hotel guests rush outside in pajamas, grabbing children and phone chargers, not knowing if the ground will still be there tomorrow. Lifeguard towers tilt as the seafloor pulls sand outward like a drain opening beneath paradise. By 8:15 a.m., a third sinkhole tears through the seabed near Boca Raton. The Florida Department of Environmental Protection escalates to full crisis mode. Director Amanda Torres coordinates with 15 county emergency offices as reports flood in faster than teams can respond. NOAA aircraft sweep the coastline, scanning with sonar. The first images send a chill through every command center screen. These sinkholes are not random. They are connected. An underground network is failing in real time. At 9 a.m., sharp, officials close 47 miles of coastline from Port Everglades to Palm Beach. The Coast Guard establishes no-go zones 2 miles offshore. Deputies block beach access as confused crowds demand answers. The numbers keep rising. 12,000 tourists displaced, 8 major resorts evacuated. And beneath the calm blue water, more voids are forming. The coast isn't eroding, it's collapsing. By mid-morning, the lockdown spreads like a shockwave. At exactly 9 a.m., authorities seal off 47 miles of coastline from Port Everglades to Palm Beach. Yellow tape flaps in the wind where beach umbrellas stood just hours earlier. Patrol boats form a moving barricade 2 miles offshore. No swimmers, no surfers, no boats allowed near the collapse zone. Crowds gather behind police lines, staring at water that looks perfectly calm. But beneath that flat blue surface, sonar scans reveal something terrifying. The ocean floor is no longer solid. It is breaking apart. 12,000 tourists are forced out of beachfront hotels before noon. 8 major resorts shut down completely. Suitcases roll across sidewalks as families search for rides inland. Emergency shelters open in Fort Lauderdale and West Palm Beach, filling faster than staff can process names. By lunchtime, some shelters report standing room only. At 11:42 a.m., NOAA's Disaster Response Division releases updated aerial imaging. What officials feared most is confirmed. 23 separate underwater sinkholes scar the seafloor across 15 square miles. Some are newly formed. Others are expanding hour by hour. Dr. Marcus Reynolds of the United States Geological Survey studies the images with visible alarm. He calls it an unprecedented collapse event, unlike anything in Florida's recorded history. His voice stays calm, but the numbers do not. Preliminary damage estimates already exceed $2.3 billion, and the count is climbing. Engineers warn that beaches are only the beginning. The same limestone platform under the seafloor stretches beneath coastal highways, neighborhoods, and high-rise towers. If the collapse network continues spreading, foundations built on what seemed like solid ground could begin to shift. Officials try to reassure the public. But behind closed doors, one question dominates every briefing. How far does the underground failure really go? Florida sits on a massive slab of limestone. From the surface, it feels solid. But limestone is porous, almost like a sponge made of rock. And right now, that sponge is dissolving from below. Rainwater mixes with carbon dioxide in the air and forms a weak acid. Normally, that acid slowly eats away at limestone over hundreds or even thousands of years. But something has changed. Saltwater from rising seas is pushing farther inland. The chemical reaction is speeding up. What once took centuries is now happening in months. Dr. Sarah Chen with the United States Geological Survey explains it in simple terms. The rock is being eaten alive, and the process is accelerating faster than any geological model predicted. Emergency sonar mapping reveals what lies beneath the beaches. A massive network of underground caverns stretches from Miami to Jupiter. Some chambers are 200 feet tall. Some run for miles. The images look less like solid ground and more like Swiss cheese. University of Florida researchers, led by Dr. James Martinez, build three-dimensional models of the coastline's foundation. The results are disturbing. Entire communities sit above hollowed-out chambers that were never mapped before the first collapse exposed them. Multiple stressors are hitting at once. Sea levels rise a little more each year, adding pressure to already weakened rock. Saltwater intrusion weakens limestone 40% faster than records from the last century. Temperature swings cause expansion and contraction that fracture rock even more. Dr. Lisa Wong at Scripps calls it a perfect storm for geological failure. The numbers tell the real story. Florida once averaged 2 to 3 sinkholes per year statewide. Now, collapse rates approach 12 per week in the affected zone. Monitoring stations pick up acoustic anomalies, sounds of rock cracking underwater in real time. The ground beneath Paradise is not stable. It is breaking. At 7:15 that same morning, lifeguard Marcus Johnson steps onto Deerfield Beach and freezes. The sand is coated in thick black tar, not a few patches. A solid, sticky line stretching down the shoreline as far as he can see. Within hours, cleanup crews collect more than 2,400 pounds of the material across a 12-mile stretch from Port Everglades to Pompano Beach. The first fear is an oil spill. But 6 hours later, the Florida Department of Environmental Protection rules petroleum out. This isn't crude oil, it's something far older. Dr. Angela Martinez, a marine geologist at the University of Miami, studies the samples under powerful microscopes. The lab results send a shock through the scientific community. The tar contains ancient organic material trapped inside limestone for thousands of years. Carbon dating places it between 15,000 and 50,000 years old. Material from the last ice age is suddenly washing onto modern beaches. The connection becomes impossible to ignore. Maps of tarball locations line up almost perfectly with known collapse zones offshore. Where the seafloor sinks, ancient layers are exposed. Cracks that should have stayed sealed are now open pathways to buried history. Environmental teams expand swimming bans along 31 miles of coastline. Wildlife impacts rise quickly. 47 sea turtles show signs of tar ingestion. 12 dolphins struggle with respiratory distress. Rescue centers report being overwhelmed within 48 hours. Then another warning appears. Methane readings spike in some collapse areas, hinting at gases trapped deep in fractured rock. Scientists begin to call the tar balls a geological alarm system. If material buried for tens of thousands of years is reaching the surface now, it means the fractures run deep, hundreds of feet into bedrock. The ocean isn't just swallowing sand, it's tearing open layers of earth that were never meant to see daylight again. Maria Martinez stands outside her family restaurant in Pompano Beach, staring at cracks that weren't there yesterday. The building has survived hurricanes, floods, and recessions. But overnight, thin lines have spread across the walls like spider webs. At 9:47 a.m., a building inspector delivers the verdict. The structure is compromised due to ground subsidence. Evacuate immediately. For 18 years, that beachfront restaurant carried 3 generations of memories. It is valued at $2.8 million. The insurance policy covers storms and fire. It does not cover ground collapse. Maria packs 3 suitcases and family photos while her 8-year-old daughter asks when they can come back. She has no answer. The damage is not limited to one building. Highway A1A near Deerfield Beach shows stress fractures that engineers swear did not exist 72 hours ago. Florida Department of Transportation crews measure 6 inches of subsidence along a 3.2-mile stretch. The road closes without warning. 45,000 daily commuters are forced through neighborhood streets never built for that traffic. Emergency repair estimates hit $89 million, but no one can promise the ground will stop shifting. Just before midnight, Ocean View Towers, a 22-story high-rise housing 340 residents, reports foundation movement during emergency inspections. At 11:47 p.m., a mandatory evacuation order is issued. Residents are given 2 hours to pack essentials. Elevators shut down. Elderly tenants descend dark stairwells with help from firefighters. Emergency shelters fill beyond capacity. The Red Cross opens additional facilities across Broward County, but beds run out quickly. Alongside the physical damage, a mental health crisis begins to surface. Children wake from nightmares about the ground disappearing beneath them. Anxiety medication prescriptions spike by 340% across coastal counties. For many families, the fear is no longer about storms. It is about the earth itself. December 20th, 2:34 a.m., a magnitude 2.8 earthquake strikes 15 miles offshore from West Palm Beach. Seismographs light up across monitoring stations, and scientists stare at the screens in disbelief. Florida does not have earthquakes. The state sits far from tectonic plate boundaries. It averages 0 significant quakes per year. Yet this month alone, 17 detectable tremors have been recorded across the region. Days earlier, a magnitude 2.5 event rattled near Panama City, the largest in a decade. These are not normal seismic events. Dr. Kevin Torres, with the United States Geological Survey, explains that the signals do not match traditional tectonic movement. Something else is happening beneath the limestone platform. One theory suggests that as massive sections of rock collapse, the sudden weight shifts send stress waves through the porous foundation. Another proposes that seawater rushing into newly formed voids creates pressure shocks strong enough to register on sensitive instruments. Dr. Rachel Kim at Caltech reviews the data and calls it new territory for earthquake science. The patterns are irregular. The vibrations are constant. Within 48 hours, 40 temporary seismometers are installed along 100 miles of coastline. Real-time data streams to USGS headquarters in Colorado. The sensors detect continuous micro-tremors, faint but persistent signals that suggest progressive collapse, moving through interconnected cave systems. The pattern does not stay still. It advances northward at roughly 3 miles per day. Vibrations are reported in Miami. Residents hundreds of miles away describe subtle shaking they have never felt before. Computer simulations run worst-case scenarios. If multiple cavern systems fail at once, events reaching magnitude 4 or even 5 are possible. Florida launches earthquake preparedness campaigns for the first time in its history. The impossible is becoming measurable, and the ground is still moving. Limestone does not stop at the Florida state line. The same porous rock that supports Miami stretches north through Georgia, South Carolina, and beyond. The Atlantic coastal plain runs for 1,200 miles from Florida to New Jersey. Much of it rests on similar limestone formations filled with hidden voids. Within 72 hours of Florida's first collapse, Georgia's Department of Natural Resources deploys emergency survey teams to barrier islands. Jackal Island reports minor subsidence in 3 locations. Tybee Island records beach erosion accelerating beyond historical patterns. South Carolina's governor requests immediate federal geological assessments as precaution turns into urgency. The United States Geological Survey expands monitoring networks into 6 states. Dr. Michael Torres at Duke University introduces what he calls the domino effect theory. He presents data showing that pressure changes within Florida's aquifer system could alter groundwater flow patterns across state lines. The aquifer stretches from southern Alabama to South Carolina. When pressure shifts in one region, connected areas feel it. The economic stakes are staggering. Atlantic coast tourism generates $186 billion each year. Coastal real estate across 15 counties totals $2.4 trillion in assessed value. Federal Reserve economists begin modeling scenarios where spreading collapse could trigger a housing crisis worse than 2008. The insurance industry reacts fast. Lloyd's of London reclassifies the Atlantic limestone coast as extreme risk. Private carriers cancel hundreds of thousands of policies. Coastal home sales drop 91% in 2 weeks. Mortgage lenders refuse loans near documented sinkholes. $67 billion in property value vanishes from tax rolls almost overnight. Florida's governor declares a statewide emergency and requests $12 billion in federal relief. The National Guard mobilizes. Congress argues. FEMA strains under back-to-back disasters. 1 week later, 47 miles remain closed. Seismic tremors continue spreading north. The collapse is no longer just Florida's problem. It may be the Atlantic's. 1 week after the first sinkhole opened off Deerfield Beach, Florida's coastline looks calm again from a distance. The water is blue. The sun still rises over the Atlantic. Palm trees still sway in the breeze. But the illusion of stability has been shattered. 47 miles of shoreline remain closed to the public. 23 documented sinkholes scar the seafloor across 15 square miles. Damage estimates have climbed past $25 billion and continue rising. 78,000 residents remain displaced from homes that may never be declared safe again. Unlike a hurricane, this disaster does not move on. There is no clear after. The collapse represents an ongoing geological failure with no defined endpoint. Engineers cannot rebuild on ground that continues to shift. Insurance policies specifically exclude the very disaster destroying entire neighborhoods. Government relief funds strain under the weight of back-to-back catastrophes. Beneath Miami's skyline, beneath beachfront condos and family-owned restaurants, the limestone foundation that once felt eternal now reveals its fragility. For generations, Florida sold the dream of paradise built on solid ground. That promise is now under question. Scientists continue to analyze data streaming in from sonar scans and seismic monitors. Microtremors persist. Acoustic sensors still detect the faint cracking of rock underwater. The collapse has slowed in some zones, but it has not stopped. Fractures remain open. Cavern systems remain unstable. The chemistry that dissolves limestone continues quietly, invisibly, every hour of every day. The black tar that washed ashore serves as a reminder that the ground beneath Florida holds layers of ancient history. If material sealed for 50,000 years can suddenly rise to the surface, it means the fractures run deep. What else lies trapped within those layers? What gases, what voids, what unseen weaknesses remain hidden beneath miles of coastline? Communities have shown resilience. Neighbors open doors to displaced families. Churches organize meal lines. Volunteers help elderly residents move belongings from unstable buildings. The human response has been powerful. But community strength cannot seal fractured bedrock. The economic ripple effects continue to expand. Coastal property markets remain frozen. Tourism numbers collapse. Insurance companies reassess entire regions as uninsurable. Mortgage lenders hesitate. Investors pause. When confidence in the ground itself erodes, the financial system built upon that ground begins to shake. And the concern no longer stops at Florida's border. The same limestone platform stretches north. Other coastal states activate monitoring systems for risks they never imagined facing. Geological stability, once taken for granted along the Atlantic, is now under scrutiny. The deeper fear is not just about beaches or buildings. It is about permanence. The idea that land, unlike weather, does not suddenly disappear. That assumption no longer feels safe. Climate scientists warn that rising seas, saltwater intrusion, and temperature shifts are not temporary spikes. They are long-term trends. If these stressors continue accelerating chemical reactions in limestone, the conditions that led to Florida's collapse could become more common. Not just here. Anywhere porous rock meets rising water. 3 nuclear power plants operate in regions now labeled vulnerable. Major ports that support national supply chains rest on similar geological foundations. Military installations, highways, water systems, all depend on stable ground. The beaches may reopen someday. Roads may be patched. Towers may be reinforced. But beneath the surface, the limestone will still be porous. It will still be reactive. It will still be vulnerable to pressure and change. For now, The sinkholes have paused their visible growth. Emergency crews continue mapping damage. Scientists continue studying patterns that rewrite long-held beliefs about geological stability. Politicians continue debating funding levels and responsibility. But the most unsettling truth remains simple. The ground that felt permanent was never permanent at all. Florida's geological nightmare has accelerated faster than anyone predicted. Miami's foundation has already begun to crumble in ways that cannot be undone overnight. And as the Atlantic stretches northward along thousands of miles of coastline built on similar rock, one question lingers beneath the calm surface of the sea. If the Earth itself can give way without warning, how solid is the future we believe we are standing on?